The lesson today will be over angle pairs. On this lesson, I will not be writing down everything. A lot of it will be what you need to listen to me say and write it down in the handout that was given to you. Some examples I give you might not be what's on the page. It will just be another clarification of what is already on the page. So first things first, an angle. An angle is a figure made up of two rays or sides that have a common endpoint called the vertex of that angle. Okay, on your handout you already have a picture of it, so I'm just going to give you an example. So I said it's two rays. That's one ray. That's another ray. They have a common endpoint, okay, and that's called the vertex. That's the vertex. Okay. So in the example that's on your handout, it says that the vertex is y and the sides are yx and yz, and they're both rays. Okay, there are four ways to name an angle. You can use just the vertex. So if you were using just the vertex, how would you name that example of that angle that's above? Hopefully you said angle y. Okay, angle y. This symbol here is the angle symbol. Okay, sometimes you see it like that, or you'll see people do it like that. Those are both angle symbols. Okay. Another way you can name the same angle is by using the vertex and a point on each side. When you use the vertex and the point on each side, the vertex has to be in the middle. So, for example, I could say angle x, y, z, or I could say angle z, y, x. Notice that in both, that the y is in the middle because the vertex has to be in the middle. Or you can use a number. You can only use a number if the angle already has a number in it, okay? So on that example above, you could say angle 2. Okay, now we're going to discuss angle types, so types of angles. This should be reviewed. The first type of an angle you have is an acute angle. So at the top of these columns, you need to put what kind of angle each picture represents. So the first one is an acute angle. And angle A, and under that acute angle, could be anything between 0 and 90. Okay? It has to be greater than 0, but less than 90. So that's what you would put under the possible measures part. Okay? The next one we have what type of angle. You should know it's a right angle because of the box indicated in there. So that means that angle A in that angle there, angle A has to equal 90 degrees. And these should all have degree marks. The third one is an obtuse angle. The third one is an obtuse angle. So the angle measures can be bigger than 90, but smaller than 180. And then the last one we have is a straight angle. Straight, which means A has to equal 180 degrees. Just to help with spelling, we have acute, right, obtuse, and straight. The next part talks about the parts of angles. There's nothing that you need to write on there. The interior is inside. These words will come back up, and they are very important. So interior is inside the angle, and the exterior is outside the angle. Then we have angle addition postulate. Now remember, we have already done segment addition postulate, which was part plus part equals whole. So same concept, except this was angles. So part plus part equals whole, but you're talking about angles this time. Alright, so in this one, if S is in the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. Okay, I'm going to say that again. If S is in the interior of angle PQR, then the measure in that little image measure, okay, the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. So again, part plus part equals whole. That's angle addition postulate. The next one talks about congruent angles. I did not do fill in the blank, so you need to listen to what I'm saying. Congruent angles are angles that have the same measure. Arc marks are used to prove that those two angles are congruent. So if you look at the picture on the left, you see arc marks there. Those are letting you know that they're congruent. Remember when we talked about segments? Tick marks showed that the segments were congruent. Okay, now let's talk about angle bisectors. If you haven't noticed, a lot of the stuff we talked about when we talked about segments came to the angles. Alright, an angle bisector is a ray that divides an angle into two congruent angles. Okay. So on this example here, on this picture, we have JK, ray JK, bisects angle LJM. Thus, angle LJK is congruent to angle KJM. Okay, so if you look at that picture again, you see that those arc marks are letting you know that they're congruent. The second picture that didn't have any angle measures on it, that looks like this. This is a construction, which we will do in class, of how to construct using a compass, how to construct an angle bisector. Adjacent angles have the same vertex and share a common side. Adjacent is the ones that are right next to each other. So if you look at your picture, angle 1 and angle 2 are right next to each other. They are adjacent. For example, let me show you what would not be adjacent. If I did this, let's say that touched it a little bit better. So we have angle 1, angle 2, angle 3. If I asked you about angle 1 and angle 3, they would not be adjacent because they have an angle in between them. Okay? A linear pair. A linear pair is adjacent angles whose non-common sides are opposite rays. Okay, we talked about opposite rays when we did our foldable. So I'm going to draw it as I say the definition again. They are adjacent angles, so they're next to each other. And so that means they have a shared side, so that's the shared side. Whose non-common sides, so this is one side that it doesn't have in common, and this is another one. They are opposite rays, so they're opposite rays, they're going in opposite directions. This is a linear pair. It has to make a perfectly straight line, which we talked about on the other page, which means it equals 180 degrees. Okay? The two angles together equal 180 degrees. When it's a linear pair, the angles are supplementary, which we'll talk about in a minute. So when they're a linear pair, these angles are supplementary. Okay, vertical angles. Vertical angles are non-adjacent angles, so they do not touch. Non-adjacent angles formed by two intersecting lines. So, for example, to me, I think of it like a big X. And the ones that are right across from each other, they would be vertical angles. Or these would be vertical angles. Notice that I put arc marks here, which means that they are congruent. Vertical angles are congruent. Okay, now we have complementary. Complementary angles are a pair of angles that add up to equal 90 degrees. These angles can be adjacent or not adjacent. So, for example, Those two angles are adjacent, and they're 30 and 60. So together they equal 90, so they're complementary. These angles are not adjacent. They do not touch each other, but they are 30 plus 60, which equals 90, which means they are complementary. Okay, the next one we have is supplementary. Supplementary is a pair of angles that add up to equal 180 degrees. They equal 180 degrees. These angles can be adjacent or non-adjacent also. So remember earlier when I talked about a linear pair being supplementary, this is what supplementary means. They add up to equal 180.